Alrighty guys, let's go over gravity. Okay, so gravity has a lot of misconceptions to it. The main thing you need to know is that gravity is not the same thing as mass. So gravity is actually a force, and we measure it in newtons or pounds, and this is basically how it works. So if you are made of mass, you have inertia, which we learned before, but you also have gravity, because all objects, literally every single thing in the entire universe that's made of mass or has gravity. And the more mass you have, the more gravitational force you have. And it always goes both ways. So like me sitting here in a chair, I am gravitationally attracted to the chair, and the chair is gravitationally attracted to me. We're both gravitationally attracted to the earth is gravitationally attracted towards us. Literally all objects in the entire universe, anything that has mass, also has gravitational force. Now, how strong is this force? So it depends on the masses of the two objects and the distance between the two objects. For example, we orbit the sun. So like if this is the sun, we over here are the earth. The earth and the sun are pretty freaking far apart, which is the reason why we are not currently crashing into the sun. If you moved the earth up like right here, it would probably be sucked into the sun and we would all die. So the reason it's a weaker force is because we are so far apart. However, because the sun is so massive compared to the earth, there is still enough gravitational force for us to orbit around the sun. And similarly, us being on the earth, we are gravitationally attracted to the earth with a decent amount of force because we are so close to the earth. But again, as you go further away from the earth, like if you're on the International Space Station or going to the moon, the further away you go from earth, the less gravitational pull the earth will have on you, which is why astronauts float around in the microgravity on the International Space Station. So the law of universal gravitation basically says that concept, that all objects in the universe are attracted to each other, and the amount of gravity depends on the mass and distance. So if I asked you, how much gravitational force is there between, a ball of Play-Doh that's 5 kilograms and, 20 centimeters away from another ball of Play-Doh that's 10 kilograms, that whole concept is called the law of universal gravitation. So that then brings up the question, if all objects are attracted to each other, then why don't you notice? Why aren't you floating towards another iPad in the room if it's gravitationally pulling on you? And it's because compared to the earth that we are currently on, little things like pencils, iPads, chairs, tables, cars, whatever is so tiny compared to the earth. So that makes the gravitational force really tiny to the point to where we do not notice it. All right. Here is our most important fact of the day. Weight and mass are not the same thing. A lot of people like to use them interchangeably. They are not the same thing. Weight is a measure of force because gravity is a force. Okay, so we measure weight in newtons, just like how we measure all other forces. If you're American, you also use pounds because America doesn't always use the metric system. So if we're comparing the two, mass is how much matter an object contains. It's how much stuff is inside you. And your mass is not going to change unless you chop off a leg or lose or gain a bunch of mass. Like if you eat a lot or, stop eating, your mass is relatively not going to change. If my mass is 1,000 kilograms on Earth and I travel to the moon, it's still going to be 1,000 kilograms. However, your weight does change depending on location because, again, according to the law of universal gravitation, the distance between objects affects your gravitational force, which, again, is a force measured in newtons. So if my weight on Earth is 100 newtons and I go to the moon where there is less gravitational force because the moon is less massive, my gravitational force there might be 10 newtons. Okay, so these change. Weight can change. Mass does not change unless you chop off a leg or something. And again, we measure gravity in newtons or pounds. Mass is kilograms. All right, and you can actually calculate the amount of gravitational force that you have using the F equals ma equation from Newton's second law. You don't have to know how to do this, but I'm going to show you one anyway because it's cool. So The acceleration of gravity on the Earth is 9.8 meters per second squared, and the moon's acceleration of gravity is 1.6 meters per second squared. So let's say I weighed, the 1,000 kilograms on Earth. I would simply multiply that by the 9.8, and then whatever that number is would be the amount of gravitational force on the Earth. And then if I wanted to do the same thing for the moon, I would multiply that 1,000 kilograms times the acceleration of gravity on the moon, and then whatever that is would be my gravitational force on the moon. So, fun facts. Hope that makes sense.